going to start the second session this afternoon. Excuse me. We're going to start now. We have, the session is a live coding demonstration. It's not so much that the session is live, all the sessions have been live today, nothing's been recorded. But we're going to have some very, very brave live coding going on with Diarmaid McGowan. Thanks, Diarmaid. Good afternoon, everyone. Glad to see such a big turnout for something that's potentially extremely boring. Test-driven development live. My name is Diarmaid McGowan. I'm a full-stack software engineer doing XP at Compose Labs in ANI. So basically, pair program all day, every day, TDD, CI/CD, using Node.js on a daily basis. Allstate made a big changeover in November 2015. I was part of the first cohort to have a mindset change. So traditionally, Allstate was Windows, all closed source, huge bureaucracy. They flipped it over and adopted a pivoted labs approach, whereby we do pairing all the time. We run Mac pairing stations. We use OSS libraries as much as possible, and very, very little closed. All our source is published. We try to live in a 12-factor app, and kind of a lot of the talks earlier today tied into the stuff that we're trying to do. So, and that got me here. So, TDD. Who here has heard of TDD? Who uses TDD? That's good. So test-driven development, it's called TFD occasionally from the early XP days, which was test-first development. Now TDD and TFD, some people differentiate, some don't. And basically you write the test first and then you write the code. So which brings us to good old Uncle Bob. So his 3 rules, or his laws of TDD, are we write no production code except pass the failing test. So we're not allowed to write any code at all until we have a failing test. We only write enough of a test to get a failure, and then we only write enough production code to pass that test. So it sounds very, very simple. It is a mindset change, but it sounds very simple. So we get into this kind of very, very tight loop where we do a red, green refactor, red, green refactor, and this loop that's 10 to 30 to minutes, seconds, and it just keeps going, and that's it. But once you get used to it, you get an awful lot from it. So, why use TDD? Now, there's loads of blog articles, there's loads of discussion about it, everybody has their own reasons. Some people say quality, some people say, you get a regression suite as part and parcel of it, some say it's good for design. So, I'm going to run through a coding session. Uncle Bob done it in NDC 2014, and he used the prime factors kata, and he done it through Java. So I'm going to run through the same thing in Node.js, and hopefully we'll get to a potential answer for this. So, with that, can you all see this okay, or hopefully? Yep. So at the kind of skeleton boilerplate done, it's a simple. We're using VS Code to tie into the OSS. We're using Chai for the version. We're using Node.js for the run it. So all open source stuff running on a Linux Mint OSS machine. So the first thing you notice here is this here is just like our description. So prime factors calculator, and it returns the prime numbers in an integer. And I have just a bit of boilerplate up here. That's just the name of the function. Now, to run this, you notice there's no test, so it passes. So if we just uncomment the first test, and we run it again, we get a failure. And we get this, tell us line 7 we have a failure, we expect undefined to deeply equal this. It's failing here. So that's because we're putting an undefined. So if we just change and do the simplest thing we possibly can to pass the test, and we get a pass. We go and do the same thing again. We want to do prime factors of 2. So factors of 2 is an array of 2. And again, we get a failure. So we're getting a failure here in line 9, we're getting an empty array, we're expecting an array of 2. So, easiest thing to pass that test would be just simply putting a 2 here. But that fails our first test, and there we get into a thing. So we start looking and we know, okay, we're going to have to put some bit of conditional logic in here to take care of both of them. So if we take in a parameter, which would be the number we're looking for the prime factors of, and we will return 2. And we need to initialize some way of doing this. So if we create a new variable and initialize it with the empty array, and then we try it out and we say if n is greater than 1, then we add factors dot push. So we just push it onto the array, number 2. Otherwise, we're grand and we just return factors. So hopefully this should pass. And it does. So happy days. Next thing we do, we just kind of run through it. So I should have mentioned before that the kind of way you think of prime numbers is you set up a list. You'll kind of list the prime numbers, you take the number, you divide by all the numbers in the list, and eventually you get to the prime numbers. So instead of that, we're just TDD in this out and see what happens. So we're just kind of hacking away. Or that's what it looks like. So next thing is 3. And factors of 3 are 3. Good. That's not good. So what are we going to do? Oh, I suppose the easiest thing we can do is make one small change. So there's a couple of times you can make decisions. We could put another if, we could do whatever else. If we go up here and we change this to from a 2 to an n, we can pass it. So all good, no real factors. We'll try our next one out, which would be 4. And 4 is factors which are 2 and 2, I think. Oh, so at the moment we have no way of putting 2 numbers onto the returned array. So if we change this about, we'll have to figure out some way of doing that. So the easiest thing we can do is we can do if the mod of n, mod 2 equals to 0, then we will push 2 on. And should be good. Oh, typo. So, okay, yeah. Oh, TDD works. So, and what do? And we forgot to reduce it. So, n to 2. Let's see how that works. Oh, we're getting 2, 1, so we need some kind of a terminating factor here, and we put this one in if n is greater than 1, then we'll add and see how that works. Okay, now we're starting to see a little bit of a pattern over here, which isn't very good. There's like the same conditions here and here. If we just pull it out for the time being, it looks like a potential loop coming through. So put that out and put it over here. Just make sure our test still pass. And still do, so we're good. So next one we just move on, and 5. So you'll notice at the moment it just looks like I'm hacking away. Hope for the best. If it works, it works. If it doesn't, it doesn't. Which is exactly what I'm doing. And provided the test pass, who really cares? Factors of 5 passes because we have it all taken care of. We'll get back in and we'll try the factors of 6, which is 2, 3. And you will notice that there's no list here, there's no nothing, and it's just passing tests for some reason. So I kind of had a bit of a eureka moment when I seen this the first time, Uncle Bob video, and it was like, there's no way this works, there's no way it can I help you in any way. Prime factors of 7. Yes, it's taken care of. So next one will be the prime factors of 8, which is 2 and 2 and 2. So 2 and 2 and 2. Now we don't have anything that will help us, or we don't have anything. We don't have anything that will actually give us 3 2s back. We expect this one to fail, which it does. Now, if we have a look at our code over here, we should be, if we just change this guy here from an if to a while, that should get us by it. Because a while is just a general version of an if, and we're green again. So you see now there's kind of a bit of a pattern starting to develop here, and we're starting to see maybe the start of a little engine, but we're not quite sure yet. So we'll put in another test or two and see how we get on. So factors of 9 is 3 and 3. This one I expect to fail because there's nothing to deal with a 3. I do not know why this keeps coming up. So yes, we get a failure here, and the text isn't very good. Yeah, so we're getting a 9 back instead of 3 and 3. So we can just do the same thing as the last time. If 3. So if n mod 3, we'll push a 3 on. Factors dot push 3. So now we're really starting to see a bit of a pattern here. Type of repair. Okay, what happened there now? Degree B3.
Do you need to divide by?
Oh yes, I forgot to take it back down. I haven't managed to do this once yet without mistakes, so these aren't deliberate. Try that out. Factor start push. On line 14. I have a typo someplace. It's a great job that I did decide to do live coding. So, get to this stage, and then after we do a factor start push, we need to do n equals to 3. See, does that work? That's better. So, we're starting to see here, we could continue on just writing loads and loads and loads and more of these. So, we will see that this here looks like the little engine above, and we put one test in for that just to verify it. So factors of 27 will be 3, 3, 3, and we expect this to fail, which it does because there's no way of putting them in. And from previous, we know that we can just change this like above to a while, and that should get us past it, which it does. Now, we're really and truly starting to see the engine over this other side. So over here, we're kind of breaking a lot of rules. With duplication of code, there's a slightly different way. So if we go up and we create a divisor, so we want divisor to be equals to 2. Then we can go and we can replace the hard-coded 2, so we're going from a constant to a variable. Place it with 2. Divisor. We can increment the divisor. Get rid of this here because it's not needed anymore. And give that a shot. And what have we done now? Oh yes, since we got rid of the second while, we need to create this. This if will need to become a while. And do that to me. And that gets us past the game. So, looking through this here now, we just kind of have a little engine going on that spins through all the numbers, pulls out all the factors, puts them in the array, and then throws it back. We are more or less finished, I think. So we just have to verify this out. If I take a big one and we go 2, 3, 3, 5, 7, 7, 11, we expect that to be equals to 2 plus, of course, yes, these commas don't do multiplication. 2 by 2, 2 by 2 by, these fingers work, by, multiplied by, is equal to our list. And see, does this work? And it does. So, there is another little bit of kind of little refactor we can do here now. So, because we're green, we can clean the code up and make it a little bit better. There's a fair bit of noise up here. So we can replace this while loop with a for loop. So we just bring this in as a for, we'll pull the divisor in, we'll use it to initialize, and we'll pull this as well, but we're going to increment. So we'll throw it out here, increment it each time. And does that get us by anything? We still pass, so we know we're good. So you're starting to see the benefit now of having the tests, and we can just kind of, it looks like recklessly refactor our code and make it, optimize it, make it better. And as long as the tests don't pass, or as long as the tests don't fail, we know we're good. There's another one here as well. We can change this way to a for, and we're not going to initialize this with anything. Pull this into the for loop up here. Yep. Throw that in there. And see, does that work? It does, yeah. And since that's gone now, we actually don't need this anymore. And let me just check and see. And that's us done. So you'll notice here we would have started off with the idea of a prime numbers list. We'll throw in the number, we'll run through the list and divide by all the the prime numbers in the prime factors, or sorry, the prime numbers list, and return the prime factors of a number. There's no list in here. There's no nothing. The algorithm kind of fell out of the test that we've done over here. There is one other thing that I just want to demonstrate. You'll notice down here we have a bit of text when we run it. It kind of prime factors returns the prime factors of a given integer. Now, I done this was for just to be quick. You can do the same thing and have a separate it block for each one of these. So hopefully this works. And you will notice now we have 8 tests passing, but here we get prime factors calculator, returns prime factors, and then we have the factors too. So this here becomes the documentation for our code. So instead of us having to manually create documentation after the fact or whatever else, our tests actually document our code as we write it. Each and every time we change our tests and change the literals within the blocks up here, our documentation is keeping up to date. So it's kind of just to show off that there is another benefit, there's more than one way of doing it. So that there is the algorithm done, and it fell out of actually doing the tests. So if we go back here, where was it? So the one thing you will have noticed is the code gets more general as the tests get more specific. So we started off with the code was very, very specific. We just threw back an empty array, then we threw back an array with 2, then we started throwing back an array with a variable. So each and every time the code kept getting more and more and more general. The tests got more specific and constrained the implementation code more and more with each additional test. So by the time we got to the end, yes, all our tests are passed. We know that our code works and it does what it's supposed to do. And it's got to a point where it's that general, it passes all the tests. So it's kind of the code gets smaller as the tests get bigger. So back to the original question, why use TDD? For me, it's confidence. It is absolutely nothing else except confidence. You will have noticed a few times when we were doing that yeah, things fell over and just roll it back a wee bit. I know the code worked a minute ago or half a minute ago. So I just undo 1 or 2 commands, code's working perfect again, no big deal. And then I try it in a different way and okay, works, happy days. So pure confidence. Quality is kind of like a side effect on a regression suite and everything else. Now, one of the other things is it's one of those that your confidence level will go down very, very quickly. And now there was a couple of earlier talks that hit that as well, that you need to be aiming for 100% coverage. You need to aim to have everything tested. Otherwise, code rot settles in very, very quick. And as code rot settles in, then it grows exponentially, and people stop writing tests, and it just goes to crap very quickly. So, as I said, for me personally, it's just all about confidence. It means that I can go and change anything. I can add new requirements. I can pick up a story, do whatever else at any stage. And it ties nicely in along with the functional programming concepts, whereby you're reducing, the functional programming reduces your effectful points, and then your test everything else. So it tests any place that it may have a side effect. The code for this I will be sharing. I have it up on the GitHub. The inspiration for it came from this guy here, Rob C. Martin, Uncle Bob. He done a talk in NDC 2014. He spends an hour long. He spends 30 minutes going through the benefits and what TDD is and how you should do it correctly. And most of us aren't doing it properly. We're kind of skirting around the edges, and we're trying to do bits and pieces. As I say, we moved into Compose Lab, so we're doing extreme programming. So the TFD originally and TDD fell out of extreme programming with Beck. Of course, Uncle Bob's Clean Coders videos and his books, they're big inspiration, as well as the 12-factor apps, because we tie into, we use Pivotal Cloud Foundry for our paths. So we have to do the TDD, we use Jenkins for CI, we use CD. So once we go through the TDD cycle, because we're paired, everything is peer reviewed on a second by second basis by the person sitting beside you. Once all the tests pass, we commit to Git. Once we commit to Git, it kicks off to CI. CI automatically runs the test again. Once they pass, it kicks off CD. CD puts it straight up to Cloud Foundry. So theoretically, within a few minutes of us finishing a story, piece of code, putting it into Git, and pushing to the remote GitHub, it can be in potentially production. There'll be some certain gatings and things like that, just to verify that we did fulfill the acceptance criteria that was given to us and all the rest, but in theory we can do that quite quickly. Agile Manifesto as well, just one of those good ones. That actually went an awful lot quicker than I thought it was going to go, and I probably missed a few pieces. I actually have some notes here. It was to do with Steve McCullough's talk before lunch. He talked about the continual learning. I'm traditionally a Microsoft developer. I came from a Microsoft background, Windows, VB, .NET, all that kind of thing. Part of the whole compose thing in 2015 was the mindset change, much the same as Stephen mentioned. Yeah, just dump everything, go that direction again. And I can really relate to it. The TDD itself, it's not easy. I struggled for 4, 5, 6 months. I'm only 18 months doing it now, and I still struggle. It is a big mindset change. When you start believing in it and start realising the value of it, it kind of comes more naturally. You kind of sit down and your mentality goes, I don't need to know the solution. I don't need to know how to implement something. I just need to know and understand what's been asked of me, or what the problem I'm trying to solve. So it pulls it back, and we're not just thinking about code and syntax and just the things, noise. We're actually thinking about the problem that we're being asked to solve with our code. And at the end of the day, that's what it comes down to. It doesn't come down to the software. It comes down to the solution that we're delivering. And TDD kind of allows us to look at it from a different perspective. And that's it. Thank you very much.
Thank you, Diarmaid. We have time for some questions if anybody has one. Just come over here.
Any advice if you have a reasonably complex code base that's been written without any tests, and you want to start adding tests afterwards just to tighten up the
That's
debugging?
always going to be a challenge, and we have teams struggling with that as well. One of the schools of thought is that as you start doing new work, you make sure that that's tested fully, and you kind of you break off little bits maybe that touches it. So if you're adding a new piece of functionality to a DLL or a function or a particular microservice or whatever it may be, you make sure that there's tests fully tested for that piece. That'll be unit test or test first or whatever it may be. Part and parcel of that is if it kind of touches some existing code, you may put in a test or two for it, and it's kind of cycling over time. Your test coverage will increase. It was mentioned in one of the early talks as well, is if you can test interfaces. So if you can test the interfaces into your existing code base as part of doing your new code, again, over time you'll end up with a slightly better code base. But it's a difficult one, yes, and it will be. There's no easy answer.
Another question here in the blue t-shirt.
Hi, Chairman. We were talking earlier, and I'm a lazy programmer.
Same as me.
Are there any tools or suites that you could use out there to help me fall into the success?
Well, I can give you what we use. We use Mocha as our test runner. I know there's Karm out there, Protractor for Angular and all those ones. We use Chai personally for the surgeon library because it gives you kind of nice BDD syntax, it's easy to read. There's loads of other ones. We use what's it called? Concept.js we use for UI testing, and it gives a very, very nice BDD style of doing things. You can set that on top of Selenium, which it's kind of slow, but you could also set it on top of Phantom.js. Now what we're looking at the moment is sitting on top of Nightmare. So if you use Nightmare.js, it's based on the Electron engine, which contains V8 and everything as well, and the Chromium open source browser, and it's about twice as fast as Phantom.js. Phantom.js is about 3 times faster than Selenium. So we found that we actually had to slow down a lot of our tests with weights and that with Concept.js and Nightmare.js. There's Jasmine, we've played a bit with it a couple of times for the client side stuff. There's quite a few libraries, Synon for spying, stubbing and kind of that kind of stuff. Try to avoid mocking as much as possible. If you can avoid mocking, all the better. Kind of mock where you have to. We use Supertest on the back end for the Node, Supertest and Superagent for the get and post calls. WebDriver.io for some of the stuff as well. So we have a lot of kind of different libraries for different things, different points of time. Use something like JS Hints or Standard or ACJS or something like that to make sure your code style is fairly consistent and all that as well. There's 250,000 packages in NPM now, but
there's another question over the back here.
Hi, could you speak about what your thoughts on API requests are? So should you be building in, you talked about 100% code coverage, but should you be building in things that are asynchronous that take time, or should your tests be immediate, really quick and snappy, your testing functions, or how do you deal with that?
There's this idea of the tenant build, and your unit tests anyways should be kind of, a minute, 2 minutes, something like that, as quick as possible, which means that you run them loads and loads of times. Like you're seeing that there, maybe run the tests 20, 30 times. So the quicker they are, the better. If you can tie them to try and test behavior rather than implementation in some way, shape or form, it's quite good. I can't remember the guy from the Microsoft guy, Cooper. He has a very good talk about TDD and that, and goes into the whole dynamics of how Kent Beck's idea of TDD has been taken and people have been too dogmatic and not taking the principle of what he's doing and how it should work. There's also quite a good conversation between Beck, Martin Fowler and DHH after DHH put an article out saying, TDD is dead, long live testing. And they've done I think a 5-part video call chat just running through the way it works. But now Rails is a bit more opinionated, a bit more prescriptive than Node and JavaScript, where you can do anything you want. So it's one of them. There's no right answer. Sorry. It's kind of more what suits you. But if you can test interfaces and test behavior and leave it as quick as possible, you're better off. And I don't know, I'm only a year and a half doing this, so
My thoughts are to separate things, so that you run your integration tests and your API calls to be separate, but it was just you mentioned about 100% code coverage, and I just thought, is this something that you would try to do all in one go, or would you split it?
Well, decouple it as much as possible, yeah. So if you can decouple it, tie into the other thing of horizontal scale and vertical scale, so decouple as much as possible and allow them and maybe go towards you'd be able to maybe someday go towards microservices or something like that as well. Again, it's not easily done.
Sorry, we're out of time now for that. If there are more questions, I would
later
on another round of applause.